All right, in this video, we are going to talk about how matter can change. Now, there are two major ways that we can change matter. We can undergo what's called a physical change, or we can undergo what is called a chemical change. In a physical change, no new substance is formed. So whatever substance we started with, it could be paper, it could be water, it could be some other chemical compound. We do something to it, but we don't create something new. We don't cause what is called a chemical reaction. All right. So in a physical change, we are only altering the form or the state of the substance. And some examples of ways we can do that: we can freeze it. So for example, water. If I take water, a glass of water, and put it in a freezer, the water will freeze and turn into ice. But if we were to look at the individual particles in that substance, if we were to look at the individual water molecules in that water and in that ice, they would be the same. Nothing will have changed. The only thing that changes in a change of state is how those particles interact with each other. So if I go from a liquid to a solid, if I freeze water, the individual water particles don't change. How they behave with each other is what's going to change. If I break something, so if I take a stick and break it in half, that's a physical change. I've changed what that stick looks like, but it's still a stick. The individual particles that make up that stick are still the same. I've merely broken them away from each other. Melting. If I were to take that piece of ice and melt it into water, same idea. I haven't changed what the particles are. I've only changed how those particles interact with each other. So the important part of a physical change is that the chemical composition remains the same. So we've learned about elements, we've learned about compounds. And when we take a substance and physically change it, the elements and compounds that exist in that substance don't change. The only thing that changes is whether they are physically interacting with each other or not. Now, a physical change is typically reversible. Now, this isn't always, but it is very commonly reversible. So think of our water example again. So if I take water and I freeze it, it is very easy to reverse that and melt it back down to a liquid. If I take water and boil it and turn it into steam, it is very easy for us to cool down that steam and turn it back into water. That's a very reversible change. All right. So some examples of physical changes. One is change of state. So as we've already said, changing from a solid to a liquid, liquid to a gas, and back. So an example of this, ice melting. All right. Dissolving. So if I were to take, for example, sugar and mix it into tea, then if I were to look at that substance, it wouldn't look like sugar anymore, right? If you mix sugar into tea, the sugar, the solid, disappears. But if I were to boil away the tea, I would be left with the sugar left behind. All right, so the sugar didn't go away, it just looks a little bit different. A change of form is also a physical change. So for example, chopping wood, taking a piece of paper, ripping it in half. In all cases, the substances, what they are, haven't changed. What they look like might look a little bit different, but they are still what they started, and still the same substance they started with. So these changes of state we've quickly looked at before. We can quickly look at them again. The major three states are solid, liquid, and gas. A reminder that there are other states of matter. Another one that you will see sometimes on Earth is plasma. The other states of matter are a little bit weird and only really appear when we're in extreme conditions in the laboratory. But those three, solid, liquid, and gas, are all states that we commonly see around us. And these changes of states, going from a solid to a liquid, so melting, going from a liquid to a gas, vaporization, or going from a gas to a liquid, condensation, going from a liquid to a solid, freezing, And then finally, going between solids and gases, sublimation. These are all terms that we've seen before. These are all changes of state that we're mostly familiar with. The solid to the gas is a little less common, but carbon dioxide, for example, taking dry ice and allowing it to evaporate, so turn into a gas, that's sublimation. All right, so when you see dry ice and it's used in something like a smoke machine, for example, that's solid carbon dioxide turning into gas carbon dioxide. That's sublimation. All right, so the next type of change is a chemical change, and this is a result of a chemical reaction. So we start with what are called reactants. So that's the substances, the particles, the compounds that we begin with, and then a reaction occurs between them, and we end up with what are called products. All right. So in a chemical change, a new substance is formed. So when a physical change occurs, the chemical compounds that are involved, the substances that are involved, do not change what they are. But in a chemical change, we make something new. All right. So as a result of that, we have a different chemical formula. That different chemical formula, that new substance, is now going to have different physical and chemical properties from the substance that we began with. Typically, this is not a reversible change. There are examples of chemical reactions that can be reversed, but typically it's not going to be reversible. And these chemical changes are the result of, again, chemical reactions. All right, so some examples of a chemical change: cooking an egg. If I were to take an egg, crack it, put it into a frying pan, and cook it, there's a very visible change in what that egg looks like. Instead of having a liquid yolk and a liquid albumin, it solidifies. And you can't uncook an egg. You can't turn that egg white back into the gooey, clear substance that we started with. A car rusting. So the iron or the metal on your car reacting with oxygen with the help of water and turning into rust. You can't unrust a metal. You can get rid of the rust, you can scrape it off, but you can't reverse that reaction. When you burn wood, you're causing a chemical reaction. It's actually the wood reacting with oxygen in the presence of some sort of energy source, some source of fire. And that burning of the wood is going to produce substances that have different properties from the one that we started with. So when you start with a piece of wood, it has certain properties to it. And once you burn it and you are left with just ash at the end of it, the properties of the ash, that new chemical compound, are different from the properties of the wood that we began with. One of the chemical properties of wood is it will burn. You can set it on fire, but you cannot burn ash. Ash is the result of that chemical reaction. That ash that is produced is no longer flammable. So that means it has a different chemical property from the wood that we began with. When you digest food, when you eat, you are taking food into your body to break it down and provide energy for you. That food cannot be unbroken down. You can't eat an apple and then reform an apple after it's been digested. Once it's been broken down and all of the nutrients and all of the energy has been taken out of it, you can't turn it back into an apple. It has now become something else. It has now become different chemical compounds that can be used by the body. So, how do we recognize a chemical change? How do we know the difference between a chemical and a physical change has occurred? Well, the basic rule of thumb is this. If you have two or more of the following observations, and we'll go through the list, you probably have a chemical change that has occurred. So some evidence of a chemical change. Number one, a permanent change in color. Right? So if you have two substances that start off colorless and you mix them together and suddenly a bright yellow shows up, that is a pretty good indication that some sort of chemical reaction has happened. If bubbles of gas are produced, so for example, if you take baking soda and vinegar and you mix them, and we've all done this, we've all made volcanoes when we were kids. If you mix those two together and a gas gets formed, so that foam gets produced, those bubbles of gas being produced are a good indication that there's a chemical change that has occurred. If we take two solutions, if we take two liquids and we mix them together and a solid comes out of it, if you end up with what is called a precipitate, then that is a good indication that a chemical change has occurred. If some sort of energy, so for example, in the form of heat or light, is released, then that is a good indication that there's a chemical change that has occurred. If electricity is produced, so if two substances are mixed together and electricity comes from that, well, then that is a good indication that a chemical change has occurred as well. And then finally, if you are not able to reverse, if you are not able to uncolorize, or if you are unable to turn the gas back into a liquid or a solid, then that is a good indication that a chemical change has occurred as well.